This is part 3. We'll continue with this. We're gonna do question number 6. So when you read the question first, so they tell you that they have a new drug for treatment of type 2 diabetes. They randomly assign it for 20 volunteers, and they divided this into 2 groups. One group using the experimental drug on trial, and the other one using the standard, the old drug. And they give you all the different numbers. Now, since there are 2 samples, question number 6. Since you have 2 samples, we have 10 of them using the standard, and we have 10 of them using the new drug. That would make it a 2 sample independent. Anytime there are 2 samples in the question, that's an indication that you have an independent system. It's not necessarily going to be 10-10. It could be 10 for the first one, 20, or 15 for the second one. It doesn't matter. They give you the numbers for the standard, it's called the AIC measure for the blood, and they give it to you for the standard and for the trial. You're supposed to find the average. So let's say, for example, that we make group 1 standard. So we need the average and we need the standard deviation. Hopefully they will be given to you. If not, you can calculate them yourself. I did the calculation, so you can just add them, divide by 10. That would be 1459 and 0.835 for the first group. Group 2, that would be the experimental group or the trial group or new drug. For this group, this is the first one. For this group, the average and standard deviation. Average is 1206. Standard deviation is 1.228. Now the question is, researchers feel that to fund this research, the trial drug has to lower the AIC by a full point. So this must be less than this by 1 point in order for them to continue with the trial. They want you to use alpha of 5% again, and whether or not they should proceed with the trial, and do all the necessary work with the degree freedom, and so do the hypothesis, the complete hypothesis testing. Okay. Now, since we call the standard group number 1, and remember, this is an independent system. So if this is group number 1, you know group number 2 must be less than this group 2 must be less than group 1 by 1 point, or group 1 must be more than this by 1 group. So you could do it this way. H0 for an independent system, they just equal each other. They always equal. Or you can bring this over. No, I mean, let me just wait on this, because it's easier to do HA first and then go to H0. I'm going to start with this. I want to see if mu1 is more than mu2 by 1 point. So you might tell me, but the question says less. Yeah, it's group 2 less than group 1 by 1 point. But I'm doing this with regard to, because we call the standard group 1. And it's easier to work with positive than negative. So if you're testing 2 less than this by 1 point, it's the same as saying this more than this by 1 point. So I want to see if group 1 is more than group 2 by 1 point. And if we bring this over, it will be mu1 minus mu2 greater than 1. And this one is always at equal, but since we have 1, we say equaling 1. Now, the test statistics for this, the test that we need to apply, is called the t-test. So for an independent system, 2 sample independent, the t-test is average group 1 minus average group 2, mu1 minus mu2, square root sp squared over n1, sp squared over n2. Now, we're missing SP, so you need to calculate SP first. It's called standard deviation pooling the system. SP is the square root of sample 1 minus 1 standard deviation 1 squared, sample 2 minus 1 standard deviation 2 squared, sample 1 plus sample 2 minus 1. First sample is 10, so it's 10 minus 1. And if you go back to the question, we said that the standard deviation when we calculated this, it was 835. So the first one was 835 and squared plus. So imagine I'm in the same line, sample 1 minus 1, and the standard deviation 2 is 1.228 squared. That should be the top here, over sample 1 plus sample 2 or minus 2. So we do the calculation. So we'll do the top first. And the answer for this is 1.126. So the answer is 1.1026. So knowing that, I can put everything in my t formula now. T-test, or t-stat, or t-observed. I need average group 1, 1425. Minus average group 2, 1206. Mu1 minus mu2, you get it from the hypothesis, mu1 minus mu2 is 1. Square root. Your SP is 1.1026 squared over the first sample, 1026 squared over the second sample. So we put everything together. Over 10 and squared over 10, and I get the answer to be 2.4133. So the answer is 2.4133. So I'm going to erase some of this to be able to talk about it more. I just wanted to double check the work. Oh, I put 2.5 here, where it's actually 5.9. Sorry, my mistake. This is supposed to be 5.9, so that would change the answer a little bit. So 14, 5.9, 12.06. Was it 12.06? Let me make sure. Yep. and the bottom number is 1.1026 squared and 1.1026 squared over 10. Answer is 3.1, or roughly, so the final answer is about 3.1 something. So answer is very close to 3.2%. Okay, I'm gonna erase some of this to be able to talk about the conclusion. Remember that thing that I told you to put down on a piece of paper, the general solution. I'll talk about it again. P-values less than alpha, reject H0, conclude HA. More than alpha, don't reject, don't conclude HA. Now let's see. First of all, I need to find p-value for t. If you guys remember, in one of the other videos, I talked about the p-value for z, and I told you there are 4 cases. For t, you need to do the DTT. You need degrees of freedom. You need to know what the test is and what the tail is. Degrees of freedom would be sample 1 minus plus 1. This is for a 2 sample independent. 2 sample independent, you add them minus 2. So it'd be 10 plus 10 minus 2, 18. Your test, when we calculated, it was about 3.2. And we're doing this as one tail because I told you, greater than is one tail, less than is one tail. Only time that it's two tail when it's not equal. So you go to the t table. In the t table, you go down to the degree freedom 18. Where do you see this 3.2? You're not going to see it because if you look at degree freedom 18, you'll see the last number in the degree freedom 18 is 2.898. Your number is 3.2, so it's like more than the table. It's here. If you go up to the one tail percentage, you'll see one tail or even the two tail. Anytime you go this way, percentage become less. So if you're going this way, the percentage becomes less. If you look at the one tail, starts 10%, then becomes less, 5%, then less, 2, 5, then 1. So if your number here, then you must be less than the last number in that one tail line. So all you need to know that you must be less than 0.005. That's all you need to know about your p-value. So now you're ready to make a conclusion. If I'm less than 0.005, that means my p-value is very small. P-value is less than alpha. So we're going to reject H0. We're going to conclude HA. Anytime you conclude, then we have significant results. When you don't conclude, it's insignificant. So you're concluding HA, then yes, the trial is better, or the standard is more than the trial by at least 1 point. So this medication works. HA is correct and the medication works. Now, the second part of this question, they want you to do a 95 confidence interval for mu standard minus, so do it confidence interval. So here we did it as a hypothesis. Now we're doing confidence interval for an independent system. This is the formula we need when you see a question, and this is the key word. When you see a question asking confidence interval, and you know that you have 2 sample independent, this is the formula. Average 1 average 2 plus or minus T star SP squared over N1 SP squared over N2. Now, to get the T star, to get this T star, we need the degrees of freedom. We know from earlier it was 10 plus 10 minus 2, 18. You go to your T table, and in the T table you go to the degree freedom 18, and it's a 95 confidence interval, so degree freedom 18 and 95%. You see, you look at the common number between degree freedom and 95, it's 2.101. You put everything together because you have all the information, so I'm gonna put everything together for the question. So putting everything together, let me just look at the question. Yeah. The average of group 1 has 1459. Average group 2, 1206. T star is the one we just found. SP, that we found earlier. You square this over 10, 1 point, and then 1.1026 squared over 10. So you put everything together, and that gives you, the difference between these two is 2.53. Doing the calculation of what after the plus minus, if you just calculate what after the plus minus, you find that it's 9866. And like we did for the previous question, you minus them, you add them. If you minus them, that takes you down to 154. You add them, that takes you to the 352. Now, remember when we proved earlier that the difference between them must be more than 1? This proved the same thing. Here, the difference is between 1.5 and 3.5. If it's between 154 and 3.5, so it must be more than 1. So both prove the same thing. So I'm gonna stop this video now. I'm gonna come back to do another video for the next question.